Hey, good morning, guys. Just going to continue on with our trig identities. Guys, I know that last worksheet was difficult. The idea is for us just to keep moving forward here and just, continue to try, continue to kind of look at some examples together, try some on our own, and then revisit them, you know, uh, once we see the answers in front of us. And hopefully kind of once we see it all and we get done this worksheet that you have that we're going to continue to work with today. So the last worksheet that we've been working off of was numbers 1 to 18. So I'm going to pick, I think I got about 4 or 5 problems I'm going to try to do today. They are a little bit longer, so bear with me as I try to write here on my computer. But I'm going to try to do 5 in our notes, and then I'm going to ask you to try 4 of these, okay? And again, just try it, see how far you get, use your notes, try to find examples that look like the problems that I'm asking you to do, okay? And you should see that today with the problems that I asked you to do for like your homework, okay? So we're going to start with number 2. And make sure you have your identity sheet in front of you. And the ones we're going to work with today are these even-odd identities. So I know that the identity sheet has a U, but just picture it had an X, all right? So if you were given sign of negative X, you can just take the negative and move it to the front. So it's not as easy with all of so you just got to be a little cautious with all of them, okay? Because for cosine and for secant, they become positive, okay? So if the negative identity comes out, the function is positive, all right? Whereas sine and tangent, the negative does still stay with it, okay? So what I'm going to do first here is I'm going to use my co-function identity. So I see this. I'm going to refer to the identity sheet, and I'm just going to take the negative and I'm going to put it in front. So it's going to be a negative tangent and I'm going to do the same thing in the denominator. I'm going to take out the negative and move that to in front. All right. Now, 2 negatives become a positive. So a negative divided by a negative is going to become a positive in my next step here. But I need to get secant. So again, I'm going to refer to these methods, and maybe the first thing I should try to do is just rewrite in terms of sine and cosine and see where that gets me. So I'm going to take tangent here, and I'm going to rewrite that as sine over cosine. Okay. And this sine x is still in my denominator. Now, each one of these should have an x, but it's pretty tough to write here, as you can tell by my handwriting. So I might just kind of skip them on some, but we'll see. Okay. Now, all I did there was just get rid of tangent by replacing it with sine and cosine. And I see that I need to get secant. Okay, so how can I continue to just try to simplify all this? Well, rather than divide by with fractions here, let's multiply by the reciprocal, and let's see what we get. So the reciprocal of sine x would be 1 over sine x. And notice what's going to happen now. I can cancel these out. I'm left with 1 over cosine x, which is the reciprocal for secant. And that's what we needed to get. All right. So there's the first example, using co-function. So not only did we use the co-function identity, we then used one of our methods here, rewrite using terms of sine and cosine. All right. Here's our first example. Our next example here is pretty obvious which one of the identities we're going to use here. Okay, as soon as you see these things, refer to the identity sheet. See how you would rewrite it. So I see, cosecant times pi over 2 minus x. So we're going to go right to this one right here, and I'm going to replace this with secant x. Again, where did I get that? Just refer to the identity sheet. All right, so we need to get tangent somehow. So I get it. Maybe we're a little lost right now. So we got to continue to refer to these methods. And again, the one that's going to be the most important for us is, well, let's just rewrite in terms of sine and cosine and see what we get. So I'm going to rewrite this. I'll just bring down the sine x. And secant, we know, is the reciprocal of cosine. And just by doing that, we now have sine over cosine, which we know is tangent. And we've simplified or we verified this identity. All right, this right here equals tangent. All right, 2 down. I wonder why it always does this. Huh. All right, next problem. Whoops, hold on. Sorry, guys. Okay, next problem here is number 5. All right, in number 5, again, we look to see what we're given. And by now that numerator, when you see something in that form, that should kind of stick out to you. You should see this 1 plus tangent x and say to yourself, all right, well, you know, this looks familiar. This looks like this could be one of my Pythagorean identities, right? Every time I see a 1 plus, something squared, you know, I should have that in my mind that I should look at this Pythagorean identity and I should see what I can do. So 1 plus tangent is equal to secant squared x. All right. And, you know, we see that we have tangent in the problem. So just right now, without me having to rewrite tangent, we'd have secant squared x over tangent squared x. We need to get cosecant. So maybe, again, after I take this first step, I use this identity, I should start thinking about writing in terms of sine and cosine. So I'm not going to write tangent squared x because I know I'm going to rewrite it in a different way. So I'm also going to rewrite secant. I'm going to put 1 over cosine squared. So I'm going to just rewrite in terms of sine and cosine. Can't stress that enough, that should be the identity that we need to, or the method that we really need to understand the concept of. So I didn't bother to just rewrite tangent squared x down here because I knew I was going to do what I'm doing now. I knew I was going to replace it using sine and cosine. Okay. Now, as you might notice here, what would happen with these denominators we could cross out. All right. And what we would have left would be 1 over sine squared x, which we know is the reciprocal of cosecant, right? That equals cosecant squared x. All right, guys, good job so far. All right, keep it going. And remember, you can pause this, do whatever you need, but definitely make sure you're watching these videos and it's in their entirety. All right, I can monitor that through something called Edpuzzle. I can see how long you're spending. I can see that when, you know, if you're doing it on time, you're submitting it late. No need to like submit a picture of your notes, just watch the video, okay? All right, our next example here involves a new method. So if you look on the left-hand side of your screen, what we have done so far, we've factored, we found the common denominator, we did that the other day. We've talked about separating the fraction. What we have not got to was multiply by the conjugate, and that's going to happen here. So you'll notice, like, this 1 minus. This isn't cosine squared x, so I'm not thinking Pythagorean identity. All the Pythagorean identities are all squareds. This is not. So this needs to be something where we look at it and we say, all right, we're going to multiply by the conjugate. All right. So the conjugate is the same thing, different sign, which would be 1 plus cosine x. And sorry, guys, I don't have a lot of space here. Continue to bear with me. Just be patient. This one's going to, again, be a little more writing. But we would have to multiply the numerator and the denominator by this conjugate here. All right. Everybody with me there? So this is, what number is this? This is number 6? Yeah, number 6. Okay. So we'd have to multiply the numerator and the denominator by the conjugate. The same thing, different sign. So 1 plus cosine x. Now, what I'm going to do in the numerator, I'm not going to distribute. Okay, I'm just going to set it up. I'm just going to write sine x times 1 plus cosine x. All right. Now, in the denominator, I am going to multiply those. All right. I am going to multiply. Think about foiling. When you have the same thing, different sign, it's like the difference of squares, right? And when we foil, when we multiply those binomials, there's no sense of doing the O and the I because they would just cancel themselves out. So the terms that I'm going to multiply down here would be the first, the 1 times the 1, and the last, the positive cosine times the negative cosine. And that would give me negative cosine squared x. So again, once we write something like this, we should have in our heads, oh, wait a sec, like I've seen this a lot now. I've seen this. This is the Pythagorean identity. I am going to replace this with sine squared x. All right? Using the Pythagorean identity. I'm going to rewrite that numerator over here. And I'm looking on, to see what I have to verify this to be. And I'm kind of already, I'm feeling good about it. I see that, okay, this 1 plus cosine needs to stay in the problem because, that's what we saw originally. That's not going anywhere. And now at this point, I could reduce. I can cross this out with one of these, right? This goes away. And now we verified. We have 1 plus cosine x over sine x. And you can just kind of, you can hear my daughter in the background. She's a little hungry. It's breakfast time over here. You could just rewrite this, and you have verified. All right. Done that one. All right, last problem, guys. Number 10 here. Okay, so again, it's one that you should see that is similar to something that we've already done together now. Okay, you kind of look at that numerator, and we should have this feeling that, okay, like this looks familiar to me. I think oh, you know what? I wrote down the wrong one. Sorry. This is number 8. Okay. No big deal. All right, so guys, ignore number 10. I wrote down the wrong problem. This is number 8, okay? So in number 8, what you're going to do is look at this numerator and say to yourself, all right, well, 1 plus cotangent squared. This, again, looks familiar. I should kind of have a feeling like, okay, I think what I'm going to do here is need to use a Pythagorean identity. So just go over there, check it out, see what you see. And here's cosecant. So I can replace this numerator with cosecant squared x. All right. In the denominator, we have cotangent squared x still. And I'm saying to myself, all right, well, I need to get secant. How can I get secant into my problem? All right. So what I would do from this point is try to rewrite in terms of sine and cosine and see where you go. All right, that's going to be the tool that you, or the method that you use most often. It's going to be the most helpful. So the numerator, I'm going to rewrite it as 1 over sine squared x. The denominator, cotangent, I'm going to make it cosine squared x over sine squared x. So this looks just like a problem we did earlier. And that now I can cross out these signs. We're left with 1 over cosine squared x which we know is the reciprocal for secant squared x. All right. So guys, hopefully today you're going to watch this video. You're going to take these notes into your packet. And then what I would like you to do is try these numbers. All right. Now, I did 8. You need to do number 10. Okay. So try number 7, which is an identity that you're going to use the co-function for. All right. Use the co-function identities, then rewrite in terms of sine and cosine. You're going to try number 10, which you're going to use the conjugate for. All right. Use the idea of the conjugate, which is something like we already did earlier today. You're going to try number 12, which is using the even odd identities. And you're going to try number 14, okay, which is, again, using the conjugate. Now, is there anyone? Let's see. Yeah, definitely give those. Let's throw one more on here. All right, let's throw 13. You could definitely do 13 as well. All right, 13 is, again, using co-function, okay? But just be mindful of, because it's squared, your answer will also be squared, okay? And then you're going to rewrite in terms of sine and cosine. So hopefully, guys, watch this in its entirety. You know, do those problems. Submit a picture later today. Try to get outside, enjoy the nice weather. You know, sun's already coming out. Looks really nice out today. So hope everybody's doing well, making the best of the situation. And, you know, thanks for being so responsive, and thanks for your effort. I'll talk to you guys soon.